What are nodal points, and why are they so darn useful in the realm of light and waves? I actually call them money points because they're the currency to describe and measure different variables of a wave, taking into account its repetitive nature. So our wave is propagating forward, it's traveling left or right, all the while its individual points oscillate or displace up and down. The vertical displacement is also bounded by our amplitude in both the positive and negative direction. So it has a maximum, a minimum, and zero. Within this range, we're going to hit every height in between an infinite number of points because a wave is a continuous function, and it's doing this over and over and over again in a symmetrical fashion. Luckily, usually the only points that matter to us on a wave are the nodal point, where the vertical distance is at a maximum, minimum, or zero, as I said. Now that we've established what these nodal points are, let's define a cycle of the wave accordingly. It's the horizontal distance between any two consecutive points of equal height and equal slope. Now, you may look at this definition and wonder, wait, isn't that the wavelength? And that could be true, but because we do not have an x-axis variable, we can't be certain what type of cycle we're talking about, because both period and wavelength are types of cycles with specific graphical features that distinguish each other. However, the good news is that because a cycle is an umbrella term that encapsulates both period and wavelength, whatever applies to a cycle applies to those two variables. Defining/describing our cycle with respect to nodal points, it's 4 consecutive nodal separations. And a nodal separation is simply the horizontal distance between any two consecutive nodal points. A to a 0, 0 to a negative A to a 0, 0 to an A. So if we number our nodes, we can see that a cycle gets to exactly 4 nodes later than when we started. On the flip side, if 4 nodal separations equals a single cycle, the nodal separation equals a fourth of a cycle. Another way we can describe nodal cycles is with the nodes themselves, A, 0, or negative A. And whatever type of node we start with is the same type of node that we end with. Here's A to A, and we can see the horizontal distance between each consecutive node is a fourth of a cycle. We could also have negative A to negative A and 0 to 0 displacement. Here, I've summarized all these different types of nodal cycles. Hold on a second. What about all those times when our cycle doesn't begin and end at the node? Well, in each case, if we start and end not at a node, we pass through 2 O's, 1 max, and 1 min. So did you learn the following? Nodes, or money points, are the minimum, maximum, and 0 displacement points along a wave. Because of the cyclical nature of a wave, we reach these points over and over, and in uniform increments. In fact, the horizontal distance between any two consecutive nodes is 1/4 of a cycle. Also, different cycles can be described in different ways to denote which nodes are covered and in what particular order.